Hey everybody, it's the Lotto King. How's it going? This is a non-scratcher related video, but this is a video of more of a personal video. I mention it from time to time. I've mentioned it before. It's probably been 6 or 7 months ago, and I've never given an update on it. Um, I do have that very long word. And this is a video that I'm going to show that pretty much it's more of a scientific video on how it breaks it down on how the disease is, how basically it operates and how it's passed, how you get it, and the consequences behind the disease. And we'll watch it, and then I'll come back and just say a few things.
Genetic diseases are due to inherited changes in our DNA sequence, which we call mutations. Our DNA is organized in genes that produce specific proteins. Some mutations prevent the production of a functional protein, and this may cause disease. In the nucleus of our cells, we have 2 copies of most DNA sequences. One of the copies comes from our father, and another one comes from our mother. So, an affected parent can pass along a disease-causing mutation to their child. Diseases that are caused by DNA mutations that can be passed on from parent to child are called genetic diseases. Today we're going to focus on ALD, which stands for X-linked Adrenoleukodystrophy. ALD affects 1 in 17,000 people of all ethnic backgrounds. This disease is caused by a mutation in the ABCD1 gene that produces the ALD protein. Mutations in the ABCD1 gene prevent the production of a functional ALD protein. The disease affects men more than women, who experience a less severe disease later in life. This is because of a very interesting genetic fact. I just mentioned that we have 2 DNA copies of all genes. Well, that's not entirely true. Men only have 1 copy of the genes found on chromosome X, while women have 2 copies. That is what determines whether you are male or female. It turns out that the ABCD1 gene is located on the X chromosome. So women with a mutation in 1 copy of the ABCD1 gene still have a normal copy of the gene that can make a functional ALD protein. Men, however, only have 1 copy of the ABCD1 gene, so if this copy is mutated, there is no normal ALD protein produced. So what effect does an ABCD1 mutation have on the cell? In the cell, ALD is normally present on the surface of structures that we call peroxisomes. ALD is responsible for transporting specific kinds of fats called very long-chain fatty acids, or VLCFAs, into the peroxisome where they are broken down. When a cell doesn't produce functional ALD protein, very long-chain fatty acids can't get broken down in the peroxisomes, so they accumulate. The very large quantities of VLCFAs can be toxic to certain cells, including cells that produce blood cells, cells that produce hormones, and cells that produce myelin in the nervous system, which is required for neurons to function. Therefore, patients with ALD develop very severe symptoms associated with the malfunction of these cells. Although all ALD patients share a genetic problem, or genotype, the symptoms ALD patients experience can vary greatly, and are grouped into phenotypes. The ALD genotype has 4 unique phenotypes, which can overlap during lifetime. The 4 phenotypes are asymptomatic, adrenomyeloneuropathy, AMN, adrenal insufficiency, and cerebral demyelination. The onset and severity of the phenotypes can vary from patient to patient. Let's explain how this works by talking about each of the ALD phenotypes in more detail. Let's start with the asymptomatic phenotype. All patients with ALD are completely asymptomatic for the first few years of life. During childhood and adolescence, men may begin developing symptoms, and by age 50, essentially 100% of men with the ALD genotype will have developed at least one of the ALD phenotypes or symptoms. On the other hand, women with the ALD genotype rarely develop symptoms before reaching adulthood, and then the symptoms are usually limited only to 1 phenotype, adrenomyeloneuropathy, or AMN. Adrenomyeloneuropathy, or AMN, is the most common ALD phenotype. It affects all men and most women by the time they reach their late 40s. In this sense, it is considered the default form of ALD. In other words, whether you are a man or a woman with ALD, if you live long enough, you will eventually develop AMN. AMN results from slow and progressive injury to the myelin and axons of the spinal cord and nerves because of VLCFA accumulation. Myelin serves as a sheath to protect and insulate the axons of neurons in the spinal cord responsible for movement and sensation, which are among the largest and longest cells in the body, leaving them vulnerable and harder for the body to repair. When myelin is damaged in ALD, neurons in the spinal cord and nerves malfunction. As a result, symptoms often begin as stiffness or tingling in the feet, but they always worsen over time and result in difficulty with walking, balance, and strength, as well as bowel, bladder, and sexual functions. Fortunately, the AMN phenotype appears to spare brain function. Unfortunately, we don't yet have an effective treatment for AMN. The next most common phenotype is adrenal insufficiency, which eventually affects most men with the ALD genotype, but is rare in women. Symptoms include weakness and fatigue, nausea, and low blood pressure. In ALD, adrenal insufficiency occurs when the cells that produce hormones in our adrenal gland are injured. This injury is irreversible, and the resulting symptoms of low blood pressure and fatigue can be life-threatening if untreated. Fortunately, if diagnosed promptly, adrenal insufficiency can be safely and easily treated using daily hormone supplements. This is why all boys and men with the ALD genotype should be tested regularly for adrenal insufficiency. The most dreaded symptom of ALD is cerebral demyelinating ALD, or cerebral ALD. About 2/3 of men with ALD will experience cerebral ALD. It is very rare in women. This is the most devastating of all ALD symptoms and is lethal unless it is promptly diagnosed and treated. The biology underlying cerebral ALD is similar to AMN in that it damages myelin and axons. However, whereas AMN progresses slowly and affects the spinal cord and nerves, cerebral ALD progresses much more rapidly and affects the brain. The damage to axons in cerebral ALD appears to originate with dysfunction of the white blood cells in the brain, which become injured when VLCFAs accumulate in ALD. This leads to massive inflammation that typically starts near the center of the brain and radiates outward. This inflammation damages the brain's myelin, axons, and eventually the neurons. This leads to a myriad of different symptoms that may include problems with vision, attention, behavior, and coordination. Unfortunately, many boys with ALD are diagnosed late because symptoms do not appear until the damage to the brain is already quite large. So regular brain scans help doctors detect the onset of the brain damage early. When diagnosed early, cerebral ALD can be stopped with a bone marrow transplant from a matched donor. The donor's bone marrow contains stem cells that don't have an ABCD1 mutation. These stem cells can replace the patient's defective white blood cells and stop the brain inflammation. This procedure only stops the progression of cerebral ALD if it is started very early in the course of disease, within a few months. This is why monitoring for cerebral ALD in boys and men is very important. Lastly, because bone marrow transplant carries the potential for serious side effects, it should only be used in patients with cerebral ALD. Unfortunately, there is no definitive cure for ALD, although some effective treatments do exist for cerebral ALD, bone marrow transplant, and adrenal insufficiency, hormone supplements. We can also treat individual symptoms like muscle stiffness and fatigue depending on the patient's condition. In ALD, earlier diagnosis allows for better treatment. To diagnose ALD, we begin by measuring blood levels of very long-chain fatty acids, which accumulate in ALD patients. This test can easily be performed at birth and is being added to the newborn screening panel in a growing number of states. The final diagnosis of ALD is made by identifying mutations in the ABCD1 gene, which can be done after birth or as part of a prenatal diagnosis. For example, we still cannot predict which patients will develop cerebral ALD or adrenal insufficiency. Researchers are trying to identify biological markers that can predict which patients are more likely to experience each symptom. This video has been produced by Eureka Science in collaboration with ALD Connect. Visit aldconnect.org to learn more about how you can build a better future for the ALD community. To stay in touch with Eureka Science, like us on Facebook, follow us on Twitter, or subscribe to our YouTube channel, or visit us at eurekascience.com. Thank you for watching.
Did you get all that? Yeah, it's kind of complex, but basically to break it down in this case, so Um, my mother, and actually her mother passed it to my mother. Both of them act as carriers. They essentially have no symptoms. They're just carrying this mutation. And I had an uncle who also had this disease, but at the time, no one knew because there was never any testing done or anything. And it was one of those things that didn't develop until his mid 30s. Um, and they actually diagnosed it as early Alzheimer's, which actually turned out not to be true, and it was actually AMN, and he actually did pass away at age 37. So it's yeah, it's a crazy thing. It's I call it, it's a very sick disease because you can go like your whole like beginning part of your life. I had no issues until my issues didn't start till about my early 30s, where I started noticing trouble like walking and stuff. Like nothing crazy, but like I always had a little bit of a gait and balance issues. And like one day I thought to myself, I'm like, I can't run. Like I used to do like mud runs and stuff. I literally cannot run anymore. It's just like the strength in my legs are not there. And I started with a neurologist who sent me to physical therapy, which was probably one of the best things because it's helped a lot. I still continue at home. I graduated from there, which was good, but it's progressive, so it continues to go. I'm also seeing an endocrinologist who's put me through the ringer, and I have, for the most part, there's nothing. I don't have pretty much any of the other side effects other than just walking issues and balance issues, and then the last thing I have like high blood pressure, low blood pressure, and that has to do with it. It plays technically I'm supposed to have low blood pressure, so having high blood pressure is not a bad thing in this. So they don't have me on any medications or anything. They're pretty much just like, well, ride it out. I'm like, okay. And then I have my middle brother who has like more of the cerebral part of it. He's kind of loopy, and some of you have been on my channel before, and he's called, and he just goes on and on and on, and it goes day by day. But like his walking and stuff is pretty much fine. I don't know what other issues he has that may be personal that I don't know about. And then my oldest brother, who is about 6-7 years older than I am, he has a lot of it's full blown. Like he's pretty much bound to a wheelchair now, and his speech is starting to slur, and it's the disease is hitting him, and it's hard to watch considering I'm only not many years, and it affects people at different times in different ways. So I have no clue like what my future holds, but it's one of those things that I like to tell people just so they know like what's happening, and I have a positive outlook on it. I'm trying to live my life as full as I can, best I can, My parents, obviously, they take it kind of hard because they're kind of like, well, if we would have known, we wouldn't have had 3 children, but, they didn't know. And I said, I'm like, if it kills me, I got a great 30, 35 plus years down, and, it's kind of morbid to think about it like that, but, and like with my oldest brother, we're seeing the big picture. We don't know what's going to happen. Like it's just moving so fast. It moves fast. It takes its time, but then when it starts, it can. It just depends when that time is. I mean, my time's not there now, but it could be coming. So that's what people always tell me, like, walk faster. I can't walk faster. It's it's just the strength of my legs is not there anymore, and that part sucks. But so there you have it. There's just a little background, sort of an update. Again, not much has really changed with me. I'm going back. I still see my neurologist and endocrinologist, and my oldest brother is actually going to Boston General there's a clinical trial with some medication that's used on MS patients because it's also a disease that can be confused as MS because a lot of the symptoms are on the same lines, and they're looking to see if it will help him. And it doesn't reverse anything, change anything, but what it does is slow it down. So at this point, slowing down would be a great thing, So there you have it. That's what's going on with the Lotto King. Live every day to your fullest because you don't know what tomorrow's going to bring. Thanks for watching.